Be looking at lessons 4 and 5 in the science book, starting at page 330. And again, we're going to talk about cause and effect, and you'll be doing a lot of reading along the way. But the topic today is what are magnets for lesson 4. And at the top you see that there are all sorts of refrigerator letters up there. And what do those magnets spell? They do spell the word magnets. So on page 330, there is an Explore It that you are welcome to do. It's kind of fun. If you've got those supplies, go ahead and try it. When we look at page 331, let's read. And remember, you can always go ahead, work ahead, do the pages, and then you can come back and watch the video to double check your answers. Magnets. Magnets can push or pull some metal objects. Magnets attract some metal objects, and attract means to pull toward. Magnets can repel other magnets. Repel means to push away. The ability to attract and repel objects is a property of matter. And here's a cause and effect opportunity for us. Circle the objects that are attracted to the magnet. Draw an X on the objects that are not attracted. Well, these are attracted, these are not. And tell why some of the objects were not attracted to the magnet. Well, the objects down below were not made of metal, were they? They were not any type of metal, so they were not attracted to the magnet. Now, I have a little video that I'd like to share with you, and let's watch. This is about magnets.
Science, please! The fridge is a cool place to keep food and all your cool magnets.
A magnet is a piece of metal whose magnetic field attracts other metals.
But not all other metals, only special ones like iron or nickel. A magnet won't work on plastic, bananas, or girls.
Well, unless they're wearing braces.
A magnet has a north pole and a south pole linked by a magnetic field. Like poles repel each other. Opposite poles attract. A magnet can repel or attract another magnet.
Magnets make getting around a lot easier.
Yes, I know. The compass needle has been magnetized, so it always points north. The needle lines up in the direction of the Earth's magnetic field.
That's right. Planet Earth is a giant magnet.
All right. That was kind of funny. But when we look at page 332, it talks about magnetic poles. Magnets have poles, and we saw that in the video. A pole is the place on a magnet that has the strongest push or pull. Look at the poles of the magnets. The N stands for the North Pole. The S stands for South Pole. The top picture says put like poles together, they repel each other. And the bottom picture says put opposite poles together, they attract each other. And it asks us to write why the North and South poles are attracted to each other. And we learned that opposite poles attract, didn't we? Opposite poles attract. And if they were like poles, they would be repelling. And the at-home lab asks you to do just that, to get two magnets and use one magnet to pull the other magnet. Use one magnet to push the other magnet and tell what happens when you try to put the two magnets together. Sometimes it works well and they attract, and sometimes they do repel each other. That's kind of fun too. Moving on, how magnets move objects. A magnet can move some things without touching them. Look at the picture below. The spoon is moving toward the magnet. The magnet is not touching the spoon. The force of the magnet pulls the spoon. And here's some cause and effect again. Draw an arrow to show which way the train will move. Now that train does have the magnetic end on it, so of course it is going to move toward the magnet. You've got the metal on the train, and there's probably a little magnet down here to hook it onto other trains, and they've got that all set up so that they will move toward the next magnet. Moving on. We've got lesson 5 now. So if you want to take a break and come back, that is just fine. If you're ready to move on with more, that's great too. Lesson 5 goes right along with this. What is gravity? And this lesson's rather short as well, but the Explore It talks about heavier objects and lighter objects. So you're being asked to use the zippy bags, and if you have metal marbles, see what you can do with that. If not, I don't have metal marbles. Maybe I want to just put 10 pennies, or maybe regular marbles, whatever. Something that's not going to break though, and see what you can do. Explore gravity. Looking at the gravity page on 335, gravity is a pulling force. And we saw that in the picture of the slide a while back when we were looking at the boy going down the slide. We know that gravity pulls things back down. It says gravity pulls things toward the center of the earth. Look at the girl jumping in the air. She will not float up. Gravity will pull her down. Think about when it rains. Gravity is the force that pulls the rain down to the ground. Cause and effect. What would happen if gravity did not pull on the leaves in the picture? Now my finger is not going to be able to write on my screen right now, so you're going to have to do this. What would happen if gravity didn't pull the leaves down in the picture? What would happen to those leaves? I'd say the leaves would continue to float in the air, wouldn't they? And here we see some toys and a little girl playing with them. It talks about gravity and weight. Look at the girl playing with the toy. Gravity is pulling the toy down. It looks like a slinky, and the gravity is pulling it down. Gravity pulls things toward the ground unless something holds them up. How much something weighs tells how strong the pull of gravity is on it. The table weighs more than the toy drum. The pull of gravity is stronger on the table than on the drum. The directions by the girls say draw an arrow to show how the toy moves because of gravity. And we know that the toy is going to move going down. And up above the teddy bear and drum, it says, write why the toy bear does not fall to the ground. Well, the toy bear does not fall to the ground because the table is holding it up. And kind of on the leg of the table, write whether the pull of gravity is stronger on the girl or on the balls, and tell how you know. Well, it told us earlier that if things are heavier, how much something weighs will determine how much, it'll tell how strong that pull of gravity is. So what's going to weigh more, the girl or those two little toy balls? The girl is going to weigh more, so the pull of gravity is stronger on the girl than the balls because she is heavier. She weighs more. Then we have a sink or float lightning lab. Make a boat using foil. If you have some foil around, that would be a fun project too. Put the boat in a bowl of water. Add pennies, one at a time, and tell how many pennies you added before the boat sank. That would be something fun to send a video to your teachers too. We'd love to see what you did, what you created with that boat, and how many pennies you could support. Thank you for watching.